Yes, class. Good evening. Is this audible?
Good evening, ma'am. Yes.
Good evening, ma'am.
All right. So we had completed the chapter number 2, that is electric potential and capacitance. Now we'll start with current electricity. Now this is not a part of electrostatics. Here all the concept of the charge movement means velocity, acceleration, all these terms will be considered now. Now see, under current electricity is chapter 3 of your NCRT part 1. So under current electricity, now what we'll be having? We'll be considering the charges, which will be having their velocity, which will be having their acceleration, and all the conditions of static charges. These are not now valid. If it is valid, then we'll use, otherwise we'll not use. So first topic that comes is this electric current in your current electricity. The way when we started with electric field, electric charges and field, what was the basic topic that we studied? Electric charge. And what did you notice? That till the last part of electrostatic, even till capacitance end, we kept on using electric charge. Why? Because electric charge is this basic intrinsic property of matter that gave rise to various phenomena which we had seen: electric force, electric field, all these. Similarly, the very basic unit is electric current. Now, what is meant by this term electric current? This is the basic property, electric current. So the way you say velocity is what? Rate of change of displacement, or you say acceleration is what? Rate of change of velocity. So whenever we use the term rate means what? You are changing something with respect to time. For example, if I tell you in 1 second, 5 coulomb of charge flowed away in a conductor. Then I said again after 1 second, 5 coulomb of charge flows. Then again after 1 second, 5 coulomb of charge flows. So it means in 1 second, how much charge is flowing? 5 coulomb of charge is flowing. So now I'll call this as my electric current. This 5 coulomb of charge that is flowing in 1 second. In 1 second, whatever is the amount of charge that is flowing, we'll call it as the electric current. So electric current becomes what? It is the rate of flow of charges. Rate means what? Anything that divides by time. If you divide anything by time, you get the rate of it. The way example we have as velocity and acceleration. So electric charge, electric current is what? It's the flow of charges within a conductor. But just to precise it and make our mathematical calculations, we consider only the amount of charges that are flowing for 1 second. Means charges flowing per unit time, you call it as electric current. So basic definition of electric current will be rate of flow of charges. Now, electric current is that only scalar quantity, which is a scalar quantity, but despite being a scalar quantity, it does have a direction. See, what are scalar and vector quantities? In vector quantities, you have the magnitude as well as you have the direction. And for the calculation of direction, you use your algebra laws, vector laws. In case of electric current is a scalar quantity, but it has a certain direction. But that direction is very simple. If I tell you, you know the flow of charges will flow. So if I say a positive charge is flowing in the right hand side, a positive charge is flowing in right hand side, so my electric current's direction will be the same. It means electric current will also flow in the right hand side. But if I was talking about electron is flowing towards the right hand side, then my electric current would have been flowing towards the left hand side. So in short, what we can say, direction of motion of positive charges gives you the direction of electric current, and opposite to it gives you the direction of negative charges. So direction of current, this is same as that of motion of charge for a positive charge if you have. So it is same as that of motion of positive charge. Motion of a positive charge and opposite to that of negative charge. opposite to that of negative charge. This is the direction of it. Now we have the direction, but how to calculate the magnitude? So it's in the definition only. What's the definition of it? Rate of flow of charges means charge flowing for a particular interval of time. So it means charges per unit time. That is the formula of electric current. So electric current's definition, direction. So direction again for positive charge is moving in this direction with, let's say, v velocity. So direction of current will be this one. But if I say this is a negative charge flowing in the right hand side with v velocity, since it's a negative charge, any negative charge, not only talking about electrons, any negative charge is there, then this will be the direction of electric current, just opposite to that of movement. Regarding the formula of it will be simply I is equal to Q by T. We represent electric current whenever you must have studied in your 11th standard dimension analysis. There you must have seen that electric current is a fundamental property. So fundamental properties have what? Fundamental properties have their own SI unit, have their own unique dimensional formula. So we represent current as I only, and in case of dimensional formula, we use that symbol A or sometimes I is used. Mostly A is used. So this is the symbol of current I, which is charge per unit time. Whatever is the change in flow of charges divided by the change in time. Why am I talking about the change? Because I'm talking about a specific interval. Let's say from 0 to 5 seconds, some charges have flown. Let's say from 0 to 5 seconds, there's a difference between charges. So that difference between the charges divided by that time interval, that will give me the current. So am I getting current at a particular point? No, I'm getting current for what? For a specific interval, 0 to 5 seconds, 10 to 12 seconds, any time interval, 0 to 10 seconds, time interval is there. It means I am getting what? I am getting the average current. I am getting the average current. But if I tell you that, tell me how much charge is flowing at t is equal to 3 seconds. Exactly at t equal to 3 seconds, if I want to ask that, what am I getting? I'm getting the instantaneous current. Which current is flowing at that particular interval of time? Be it 0.0003, 3.00, that is 3. Even if it's 3 or if it's 0.0003, infinitesimal change also, you can calculate the electric current. So current is what? dq over dt, means whatever charge is given to you, just differentiate it. So you will get the instantaneous current. Also, don't forget that it's a scalar quantity. And the SI unit. Can anyone tell SI unit?
Coulomb per second.
Coulomb per second. And 1 coulomb per second is also written as ampere. So 1 coulomb per second is ampere. So we'll be using ampere only. Capital A is the symbol of it, ampere. So this was the introduction of this chapter and the basic definitions of electric current, and questions do come from this part. Numericals come from I is equal to dq by dt and delta q by delta t. So you should know when to use delta q, when to use dq. So that question we'll do, but before that, just note it down. Okay, one more thing. Can you tell me whose paper is this? Is it from your batch? Anyone's paper? Okay, Fatima Munir. It's yours. So this must be, this is your paper, Fatima? Fatima Ansari.
Yes, teacher.
So I think Akifa has scored full. Is Akifa here?
Yes, ma'am.
Yes, Akifa is with. Okay, let's discuss the paper as well because this was pending, no? So then you can start writing it down. See, Akifa's from here also. Let's see. In this question, the first question that was given, you were given the radius of the circle. Radius was what? 10 centimeters. And charge was given as 200 microcoulomb. So convert it. After conversion, you will see 10 into 10 to the power minus 2. You will see 10 into 10 to the power minus 2 and charge will be 200 into 10 to the power minus 6. Put V is equal to KQ by R. You have to get the potential. K is 9 into 10 to the power 9. Q is 200 into 10 to the power minus 6. R is 10 centimeters. That becomes 10 to the power minus 1 meters. So you will get the answer as 18 into 10 to the power 6 volts. Regarding the second question, what happens? Few drops coalesced and formed a bigger drop. Now see, if I say in this batch, for example, let's say 9 students are present right now. I shift you to one room each. Everybody is there in a single room. There are 9 rooms and 9 students are there. But if we are there in a single room, if all those 9 students are there in that same single room, in one room, then what will I say the number of students? Number of students will still be 9 only. If you separate them or if you put them together, number of students will remain the same. If 9 students are there, 9 students will be here. Similar is this case. If you say few drops are there, they're combining to form a bigger drop. So what is happening? Few drops are forming the bigger drop. No additional drop has been added, no drop has been deleted. It means the volume will remain the same. So if you equate the volume, means what was the initial volume to the final volume. Initial volume means volume of the small drops and volume of the bigger drops. What will happen? Volume of a sphere is 4 by 3 pi r cube. So 4 by 3 pi r cube is equal to 27 4 by 3 pi r small cube. Means 27 small such drops have combined together to form a bigger drop. So in this manner, what will happen? Volume of these 27 times a single drop is actually equal to the volume of this bigger drop. So just equate this, get a relation between R. This comes out to be 3 times the smaller. Now you can take the ratios of both of them. Charge will be 27 times the smaller charge. Charge will also become 27 times, no, of this. So you will get 9 times V. If you multiply it, 9 multiplied by 220, you get the answer as this, 9 into 220 volts. Then the third question. Yes. In the third question, you had to find the neutral point, no? Where the neutral point was there. So assume x from 1, then that becomes 15 minus x from the other one. So see, just equate kq by x for potential is 0. So it will be kq by x. Find out the value of x from this manner. Just take the neutral point. Potential at both of them will cancel each other. So kq by x will be equal to kq by the other one, 15 minus x. So you will solve it, you'll get the value of x from one end, subtract it, you'll get the value from the other end. That was the third question. Okay, the fourth question. Fourth question was what? You had to find out the potential. V1 is there, V2 is there, V3, V4. So net potential will be what? Sum of all the potentials. So potential of 1 is what? KQ by R. So potential of each one calculate KQ1 by R, KQ2 by R, KQ3 by R. In this manner, write it. So net answer will be 9 into 10 to the power 4 volts. Fifth one was a derivation. Using your work done, you have to derive the potential. So her Akifa's paper was nice. Krishna, I think you had not done 2 questions. Krishna?
Yes, ma'am.
2 questions were there. Now understood?
Yes, ma'am.
Okay. Krishna, then Atif is now in this batch, no? Atif is there in today's class? Oh, yes, yes, Atif is there. Atif, very slight mistake that you did in both the parts. In this part, you've got 4.5 into 10 to the power 4. Just calculation error. Otherwise, your paper was fine. Hanifa is in this batch. Hanifa is there? Hanifa is not today. Fatima, both the Fatimas are there, not today. This is Fatima Ansari. So that potential one was wrong that we have discussed. Otherwise, rest was correct. Fatima Munir, you left few questions, I think. You have not attempted. Whichever question you attempted, those were correct. Yes, this derivation. See, this derivation does come in your exam. The derivation for potential due to point charge, derivation of electric field due to point charge. These questions do come in your exam. So don't leave the derivations. Hamzaz was also correct. He has left a question, I think. One question, Hamza, I think you left. Otherwise, your paper was correct. Whatever you have attempted. And Hiba, same with Hiba. All right. Okay, start noting it down. Then we'll do questions on this current question. Fatima, how was your exam today?
Teacher, it was good. Most of the questions from my set was only, derivations. Only 2, 3 questions were calculations.
All right, all right. So it went fine, no?
Yes, teacher.
Yes, Kulsum, your paper, can you tell me, is your paper this one? And one more, Huzefa was also there, no? Who he appeared for the test. One paper was there. Nifa, Khipa. One paper was there, Kulsum. I was asking whose paper because there wasn't any name. So I was not able to identify. I'll see once again. Huzefa, you have also submitted. I have received Huzefa's paper. Huzefa Ahmad, you there in the class? Yes, Huzefa is there. Huzefa, do one thing. Today only, after the class, when we complete the class, do one thing. Send your answer in a PDF. I got those images. Just make it and convert it into a PDF. Okay, no, this paper was there. This was Fatima's. Kulsum, you have written your name on the top. Kulsum?
Yes, ma'am. I've written my name on the first page on the top.
Okay, I'll check it once again. I'll check. This paper was missing. So this was Fatima Munir's. I'll check Kulsum. If you've done, I'll check it again. And Huzefa, just convert it and send me in the form of PDF.
Okay, ma'am. Thank you.
Ma'am, by chance, do you have the question paper still?
Yes, yes. I'll be having the question. Who asked? Krishna?
Yes, ma'am. Can you just show it once?
Right now?
Yes,
Okay,
ma'am.
okay. I'll show. Just note it down. I'll show. This was your paper, Krishna.
Okay, ma'am. Thank you, ma'am.
Okay, take the screenshot if anyone wants to take the screenshot.
Done, ma'am. Thank you.
Alright. Now let's do some question on this. Basic formula-based questions. See, this is interval given to you, 0 to 2 seconds. And this is you have to find the current at exactly at t is equal to 2 seconds. And this is the current here. Just try. Take 2 minutes. The calculations are easy. Also, please send your PDF once again. They haven't submitted me all the PDFs that you have forwarded to the team. Yours is not there. It's Hanifa, Akifa, Krishna, Atif. Huzaifa's images are there. This is Fatima Munir, Hamza, and Hiba. Only these are received. Could you just resend them, and Huzaifa, you also. After the class, or if you get time within.
Okay, ma'am, I will.
Okay, thank you, Josefa. I've received yours. I'll check it after the class. Yes, Krishna. Second part's answer is correct, but try the first part as well. First, do one thing. At t is equal to 0, what will be the charge? Then at t is equal to 2, what will be the charge? Take the difference, divide by the time interval. You'll get the current. Last 1 minute, then I'll discuss it. Everyone is solving for the second part. There's a first part as well. Okay, let's discuss it then. So charge is given to you 3t square plus 2t plus 1. So you have to find the current in 0 to 2 seconds interval. So see, delta Q means what? Change in the charge. Charge, one charge minus second charge. And interval change in time means what? Final time minus initial time. So at t is equal to 0 seconds, if you calculate the charge will be, just put 0 instead of t everywhere, 0 plus 1. Q at 0, this will be 0, 0 plus, this is 1 coulomb. So charge at t is equal to 0 is 1 coulomb. Then charge for 2 seconds. This becomes what? 3 2 square plus 2 multiplied by 2 plus 1. What I have done? Instead of t, I have written 2. So 2 square is 4. 4 multiplied by 3 is 12. 12 plus 4, this is 16 plus 1, 17. So Q2 is what? Q2 is 17 coulombs. Now see, finding out electric current. Electric current is what? We are getting the average current. Reason? That's the time interval given. So it will be delta Q by delta T. Delta Q means the change in the charge. That is 17 minus 1. And delta T means the time interval. Time interval is what? It's from 0 to 2 seconds. No, so this becomes 2 minus 0. So this becomes 17 minus 1 is 16 divided by 2. So current is 8 amperes for the first part. Second part, few students have tried it and 14 ampere was the correct answer. Somebody was getting. Krishna's second answer was correct. Not 6 ampere Krishna first part, it would be 8 amperes. Yes, Akifa. Okay, Akifa has submitted the correct answer for it. So charge was what? Now current will be dq over dt. Now we are getting current exactly at t is equal to 3 seconds or 2 seconds? 2 seconds. So we'll differentiate it. Current will be what? Differentiation of what? Whole charge. Whole charge is given 3t square plus 2t plus 1. We are differentiating this. That's why we had revised differentiation and integration when we had started potential and capacitance, because it will be used throughout. Now 3t square. 3 is a constant. It will come out. Powers, if it is t to the power n, it becomes n t to the power n minus 1. Here t square, your n is 2. So 2 will come out, t to the power 2 minus 1 plus 2 will come out, t to the power 1 minus 1 plus constant differentiation is 0. So I is what? 3 multiplied by 2 is 6, t to the power 1 plus 2. Now time is given to you what? T is equal to 2 seconds. Current will be 6 multiplied by 2 plus 2. So this gives you 12, 13, 14 amperes. So current over in the second part, this is 14 amperes. Clear? Okay, so all those you have not done, just write down the section. Okay, so it says, the next question says, an electron is revolving around a nucleus with frequency nu. You have to calculate the current. So can anyone tell me what is the relation between time period and frequency? Time period and frequency, time and frequency. No one?
Frequency is equal to 1 by time period.
Good, correct. Frequency is 1 by time period. Frequency is basically 1 by time period. Okay, in the beginning of the classes when we were studying electric charge, there we had studied electric charge property. One property was quantization of charges. So
Q is equal to NE.
Q is equal to NE, perfect. So Q is equal to NE means charges are integral multiple of E, that is the electronic charge. So electron is given. So this will be what? If let's say charge that is flowing, this is charge flowing is E. So current will be what? Current will be minus, this is charge divided by time. So charge is what? Charge is, let's write minus C, so as to represent this is a negative electron is there, divided by time. Now time can, 1 by time can be written as what? Frequency. So this becomes current. Now this is valid for what? This is valid for 1 revolution. Electron is there, nucleus is there, electron is revolving around this nucleus. Fine. Now electron is revolving around the nucleus, but this completes 1 revolution if it starts from this point and then moves around it and then comes back to this point. That it means it has completed 1 revolution. We don't know how many number of revolutions are there. For example, if it makes 2 revolutions, then it will be 2 times minus E nu. If it makes n revolutions, so that will be minus n E nu. Minus n E nu, this is for n revolution. This becomes minus n E nu for n revolutions. Revolutions. N number of revolutions are made this way. Now one more thing regarding charge and time. If I plot a graph between charge and time, no, let me draw the graph. Whenever you want to know the slope of any graph, just divide the two quantities, means take the ratio of y-axis and x-axis. For example, if I say charge versus time graph, if I want to know what is the slope of this graph, means this is the slope, this is the angle. What is the slope of this graph? Slope is always given by tan theta, which is tan theta is equal to what? Perpendicular divided by base, means y-axis divided by x-axis. So this means what? Q divided by T, and Q by T is current. It means the slope of Q versus T graph gives you electric current. Whenever, in general also, whenever you're solving different questions, if you divide two quantities, you get the slope. You divide two quantities, you get the slope. Now, if you multiply two quantities, then that is given by the area. Division, slope. Multiplication gives area. For example, if I say I plot a graph between current versus time. This is my graph, current versus time. This is angle theta and this is the right angle triangle that is being formed. Now, whatever will this area be, this complete area, whatever this complete area will be, that will give me the product of I versus T. So I multiplied by T gives you what? If you multiply I and T from here, that gives you charge. So area of triangle is given by I multiplied by T, that gives you charge. So if you multiply two quantities, then that is given by the area of the graph. And if you take the ratio of two quantities, you divide it, then that is given by the slope of the graph. So this also you should remember that this will be utilized in your Ohm's law also. So note down these two things. If you are having any doubts in this lesson, just ask me, or the previous lessons also. You can text me in the chat box. After the class, I can explain, or in between also, from chapter 1, and start preparing your chapter 1 and chapter 2 very well, because both of them are over and we're on the third one now. All right, the next topic is drift velocity. See, what is a conductor? A conductor is a material that allows electric current to pass through it. How does it allow electric current to pass through it? Basically, it allows electrons to pass through it. So electrons will flow, charges will flow. It means electric current will flow. So if let's take conductor, let's take the cross section of a conductor. We have taken a conductor. Now, what does a conductor contain? It comprises of positive ions which are immobile, some positive ions which are immobile, and it contains electrons which are mobile elements of a conductor. Now, what happens? These electrons, as soon as we apply electric field on it, we apply electric field means when this whole setup is connected to a battery cell, it is connected and electric field is generated. So all the electrons will get attracted towards the positive terminal, because positive terminal will attract negative charges, and negative charges are electrons. So what happens in this hustle bustle, these electrons collide with these positive charges which are static and immobile, as well as they collide with the walls of the container. Walls of the container means the walls of the conductor. So each electron will be having its unique velocity. Some electron will collide with the positive charge, few electrons will collide with the wall of container, few electrons will collide among themselves. In this manner, all the electrons will keep on colliding. Now, in this collision, each electron has its unique velocity. Each electron will be moving with different final velocities, initial velocities, different accelerations, different time intervals. So, the net velocity with which the whole electric current is driven means the average velocities of all the electrons that are moving. You call that velocity as a drift velocity. So drift velocity is what? Drift velocity is the velocity with which the electrons drift towards the positive end. Positive end means positive terminal of the battery, of the conductor, when electric field is applied to it. So each electron will be having what? Different initial velocities. But see, initial velocity will be zero. The sum average of all initial velocities will be zero only. Reason is that electric charges means these electrons, these are static right now. When electric field is applied, then they gain motion and then start moving. Initially, they are at rest, no? So initial velocities is zero. But they'll be having different final velocities. So average thermal initial velocity will be zero. First, let me write down the definition of drift velocity. Drift velocity is what? It's a velocity with which electrons drift towards the positive end, drift towards the positive end of conductor, positive end of conductor. Velocity, basically average velocity, because calculation of each single velocity of every electron is not possible. So it's the velocity with which all the electrons drift towards the positive end of conductor under the application of electric field. Under application of electric field. So let's say U1, U2, U3, UN, n number of electrons, charges, these are there. So average thermal velocity will be what? Initial average velocity. This will be U1 plus U2 plus how many number of initial velocities are possible? UN divided by n. This is the average. Average thermal velocity. Average thermal initial velocities of all electrons. So since there is no need of movement of electrons across the conductor right now before application of electric field, this is zero. Okay, next thing, F is equal to what? Okay, Hamza, you tell me what is the relation between force, charge, and electric field? How can you relate all these three with a single equation? Yes, Hamza? Charge, electric field, charges, electric field, and force. How can you relate all of them? Kulsum? Electric field's definition, try to recall, it was the force per unit charge. So force will be equal to what? Zephyr?
Electric field
Yes, Kulsum?
force by charge.
Electric field
No.
is force by charge. Yes. So force will be?
E is F by Q.
E is F by Q. So F will be?
Q into E.
Q into E. This was it only. Don't forget all these things. These will be utilized in your constant derivations. All right. So good, Kulsum. It will be E is what? F by Q. So F will be Q divided by E. Here you have the charge as electronic charge. This will be your force. Hamza, now you tell me, how will I write acceleration? What is the relation between force, mass, and acceleration? Hamza.
F is equal to ma.
F is equal to ma. So A will be, Hamza? F is equal to ma. So A will be?
M by F.
F is equal to ma. See. F is equal to ma. Now tell me, A will be? M by F?
F by M.
F by M. All right. So it will be F by M. So acceleration will be what? This is the force that you have. Acceleration will be E divided by M. M is what? M is the mass of electron. E is what? E is the electronic charge. Fatima Munir, tell us what is the electronic charge? Charge on a single electron. Fatima, what is the charge on a single electron? Fatima Munir. Okay, so this was the acceleration. Till the time we are discussing, Fatima, you send the answer. So this is the acceleration. Now see, what happens? You have a certain relaxation time. Relaxation time is basically the time interval between two successive collisions. What happens when electrons are colliding? When two electrons are colliding together, then one collision will be there, electron will take a rest, then it will collide with another one and then take a rest. That resting period is known as, okay, 1.6 into 10 to the power minus 19 coulombs. Good. This will be. Yes, coulomb. Fine. Good, all of you. So see, what I was telling, yes, relaxation time. So between two successive collisions, there's this relaxation time, this gap interval of time where electrons are not colliding, they're beginning to collide. That interval, we call it as a relaxation time. So relaxation time. This is represented by the symbol tau, which we often use for torque, calculation of torque, but this is used in this also, relaxation time as well. So this is the time interval between two successive collisions. Now, if you remember, V is equal to U plus AT from your motion in 1D. Final velocity of first electron will be what? U1 plus A tau 1, relaxation time for the first one. For the second electron, it will be U2 plus A tau 2. Why am I writing V is equal to U plus AT? I'm just putting values of each electron there. N number of electrons are there. So Vn will be Un plus A tau n in this manner. All right. Now, if I want to write the average velocity, because these are individual velocities of every electron, that is of no use to me. Why? Because whole electrons group is drifting. So calculating and writing for each is not possible. So let me take the average of it. Average velocity, and what did I tell you? That average velocity is basically the drift velocity. So drift velocity is, this will be v1 plus v2 up till Vn whole divided by n. This is how you take the mean value, average value. Now put all these value in here. Vd, V1 will be U1 plus A tau 1. This will be plus U2 plus A tau 2 plus up till Un plus A tau n divided by n. Now let me separate U terms together and A terms together and T terms together. I can separate. No, these are just dividing by each of them. Vd will be what? This will be U1 plus U2 up till Un divided by n plus acceleration, whole acceleration divided by n plus tau 1 plus tau 2 up till tau n divided by n. So this is what? This is the average initial velocity, which is equal to 0. And this whole is what? This is the average relaxation time. So this, let's represent it through tau only. Vd becomes what? Vd becomes, this becomes A tau divided by n. A tau divided by n. And not even n. See, acceleration is getting multiplied. No. So 1n will also already be considered. This is not addition symbol. See, in this, acceleration is getting multiplied by relaxation time. So here it will get multiplied. I had written plus sign. Just make a correction there. It is getting multiplied. So we cannot write it separately for a 10. So this will be the drift velocity. Now, what was the value of acceleration that we wrote? Minus E, capital E divided by m. This was your acceleration. Put it. Drift velocity is what? Minus E, capital E tau divided by m. This is the formula of your drift velocity. This term is your drift velocity. Rishan Mirza. Rishan, you tell us, what is this capital E? Yes, Rishan. See, tau is the relaxation time.
It will be A tau by n, right?
Yes.
It will be A tau by n, right?
8 tau by n. No, see, all this n, this whole average, we have written it as single tau. Because average time interval we are taking for every time interval. No. So tau 1 plus tau 2 plus up till tau n divided by n. That whole complete thing we have written it as tau. That is the average relaxation time for the whole drift. All right, Atif?
Yes, teacher.
Rishan, you didn't answer? Electric field.
Ma'am, why U1 plus U2 by n will become 0?
Because initial velocity, all the electrons before the application of electric field are at rest only. No, that's why we were able to study electrostatics. Now, after application of electric field, then electrons begin to move and then we get a final velocity. So initially all electrons are at rest only. That's why. All right.
Yes, ma'am.
So yes, Kulsum, right. It is electric field. Capital E is the electric field. Small e is the electronic charge. Electronic charge means charge on electron. And m is the mass of electron. Do not take it as the mass of conductor. One thing that you have to remember, that in this average relaxation time, if your temperature increases, or if let's say temperature decreases, then your drift velocity also decreases. If there's a decrease in your temperature, it's the opposite. If your temperature decreases, then your average relaxation time, this increases. Tau increases. These have opposite relations. So if you decrease time, tau increases. So if tau increases, what will happen to drift velocity? Will it increase or decrease? It will increase. It will increase. Good. So this drift velocity, this will increase. Opposite to it, if you increase the temperature, tau will decrease, BD will decrease. So just remember this relation with the temperature. Else we'll do this in detail for semiconductors, conductors, insulators, metals, and electrolytes, a variation of temperature and all those. But right now for average relaxation time, remember. So you have to write from drift velocity, no? Is this clear to all of you? Rishan, is it clear? Okay, Rishan.
Ma'am, can you scroll bit up?
This much?
Yes, ma'am. Done, ma'am.
Done. By now, all of you must have written. Okay, so let's. This one is easy. Drift velocity's derivation was quite long. This is a short derivation for establishing a relationship between the electric current and drift velocity, and this formula is also used. Derivation does not come so much of this. Derivation of drift velocity does come, but
This
of
came
this
in my exam today. The
this
same one.
this same thing, relation I is equal to any AVD. Okay. So in this you can get derivations as well as you can get questions also. Numericals do also come from this part. For example, let's say this is a conductor. So were you able to do it, Fatma?
Yes.
So are your exams over now, or any other subject is left?
On Sunday I have CS, then it's over.
On Sunday you have?
Computer science.
Okay, so again, positive ions are there and negative electrons are there in the conductor. So electrons are also moving and electric current will flow in the opposite direction to it. Now let's say the area of the cross section of the conductor is A. So let me write it. A, this is the area of cross section of the conductor. And let's say small n, this is the length of the whole conductor. Is the length of the conductor. L is the length of conductor. N is number density of electrons, means number of electrons per unit volume. Number density of electrons. And Vd is your drift velocity. Vd is your drift velocity. Okay, so velocity's definition is what? You have velocity with you. How can you write velocity? What is the formula of velocity in terms of distance and time? How do you write the definition of velocity? Formula of velocity is what?
Distance per unit time.
Distance by time. So time will be what? Distance by speed. So time is what? Distance here covered by the electron is the length of the conductor. So your distance becomes the length of conductor divided by the velocity. And velocity is what? Here we are talking only about drift velocity. So this becomes your drift velocity. Now if I say capital N, this is the number of electrons, total number of electrons. Let's say capital N, I have assumed that this is total number of electrons, and V is the volume of conductor. Volume of the conductor. So volume is written how? Volume is written as the length multiplied by the area of the cross section. So volume will be length multiplied by the area. Now n is number of means total number of electrons. So it will be small n, that is number of a single electron multiplied by the total number of means total volume. So capital N becomes what? N times L A. What did I do? Volume I have written. This is capital V is the volume. Volume is written how? By the product of length and the area. Then capital N is the total number of electrons. Total number of electrons is written in which manner? Number of electrons multiplied by the volume. That will give you total length. No, total number of electrons. So putting the value of V is equal to LA, I get capital N as NLA, small n, L and A. Then the way Fatma, you have told us when we were discussing that quantization of charges. Quantization of charge was Q is equal to NE. So again, if I use that, Q is equal to capital NE. So putting the value of N from here, I get it as N, L, A and E. This is the charge that I have. Now, writing the definition of current. Formula of current is what? This is charge per unit time, Q divided by T. Q is here. This is your Q from this equation. Let's say this is equation 2. And this is your equation 1. This is the times equation. If you put 1 and 2 in this, let's say this is equation 3. So put 1, 2 in 3. What do you get? Current is charge, that is NLAE divided by time was what? L divided by VD. So VD will go up. Length gets cancelled. Current comes out to be NEA. This is a relation. So this is a very easy derivation as compared to the derivation of drift velocity. But here you should remember few points that can come in your theory questions, theoretical questions. See, it looks here that current is directly proportional to the area, but current is independent of area of cross section. I is, let me write current. Current is independent of the area of the cross section. This is current is independent of the area of cross section. Current is independent of the area of cross section. But drift velocity and area, if you see, drift velocity can be written as what? I divided by NEAVD. Not NEAVD, NEA only. From this equation, you can see current can be written as NEA. So this shows that drift velocity is inversely proportional to area, and this is valid. But currents one is not valid. Current and area, that is not valid. It looks like current is directly proportional to area of cross section. For example, if I have a non-uniform cross-sectional area in this manner, this is A1, this is A2, current is flowing, this is I1, this is I2, drift velocity is there, 1, drift velocity 2 is there. If I say A2 is greater than A1, as you can clearly see that the A1 has narrower diameter and A2 is wider than A1. So A2 is greater than A1. But I won't write I2 is greater than I1. I1 and I2 both will be equal. Because the number of charges entering, that will only be exiting from the other end. That's why current remains the same. But velocity can vary. No, velocity is not depending on the number or amount of charges. It depends on the area. So if A2 is greater than A1 and VD is inversely proportional to the area. Hiba, tell, will VD1 be greater than VD2? Will VD2 be greater than VD1 or VD1 will be equal to VD2? Drift velocity is inversely proportional to area. A2 is greater than A1. Rest of you, till the time Hiba is answering, reply in the chat box. What will be the relation between VD1 and VD2 if A2 is greater than A1? Yes, Hiba. Krishna, Akifa, Atif. Only 3 students? Fatima? Fatima? Kulsum? See, if one quantity is inversely proportional to other, then the ratio will be opposite. If A2 is greater than A1, then drift velocities will be opposite. VD2 will not be greater than VD1 because A2 is greater than A1. If A2 is greater, means if area is high, it means velocity of that region will be low. So if A2 is greater, VD2 will be low and A1 is narrower, so VD1 will be high. It means VD1 will be greater than VD2. This will be the relation. Yes, so I is equal to NEAVD. You should remember N is number density, E is the electronic charge, A is the area of the cross section, and VD is the drift velocity.
Ma'am, please scroll up. Okay, ma'am, thank you.
See, Ohm's law says what? Ohm's law is also a very easy law. This just says that if the temperature and pressure does not change of a conductor, means temperature and pressure that remains same for a conductor, then all of your voltage that is there in the circuit connected for the cell, it will be directly proportional to the current flowing. This is simply statement of Ohm's law. First point is what? Temperature and pressure should remain constant. So let me write down the law. It says that at constant what? Temperature and pressure. At constant temperature and pressure through a conductor, the current that is passing through it, all the current that passes. So at constant temperature and pressure, current through a conductor, this is directly proportional to, this is directly proportional to the potential difference applied across its ends. Proportional to the potential difference applied across its end. Means if this is your conductor, P is the potential difference, I amount of current is flowing, then all this potential difference is directly proportional to this current. And how do you remove the proportionality sign? You put an equal to with a constant. That's how in mathematics we remove the proportionality sign. So here also you will put an equal to with a constant, not K we are writing it as R. And this R is only known as resistance, which you must have heard of. Resistance is basically opposition to the charges offered. Whatever opposition or resistance basically means opposition only. So opposition to the flow of charges. So resistance, resistivity, that we'll do completely in the next class. But right now, whatever is the constant, you should know that this constant is resistance. So the formula becomes V is equal to IR. This is your Ohm's law, where R is your resistance and I is your current, V is the potential difference. So if you plot a graph between V versus I, if you plot a graph between V versus I, this graph, Then what will be the slope of it? This is V versus I graph. Slope means tan theta, which is what? V divided by I, and V by I is R, because V is equal to IR. So V by I, this will be equal to R. Now if I reverse it, if I draw the graph between I versus V, instead of V versus I, if I plot a graph between I versus V, this graph, this will also be a straight line, but the slope here will be tan theta will be equal to what? I by V. So that is not equal to R. I by V is 1 by R. So this is I versus V graph. All right, so note down Ohm's law. We'll do a question on graph, the questions based on graph. We first note down this law, then we'll do a question on it. Kulsum, I have received yours now. Okay, Kulsum.
Okay, ma'am.
Yes, good Krishna. Root 3 for the first part and second part is 1/3. Good, correct. Rest of you also, you should have tried it. See, it is I versus V, means slope is given by what? Slope is given by tan theta. And tan theta is equal to I by V. I by V means 1 by R. So R will be equal to what? If tan theta is equal to 1 by R will be given by 1 by tan theta, and you have to find out R only. So resistance for the first part, this will be RA, resistance for A, it will be 1 by tan 30 degree. So tan 30 is 1 by root 3. So this becomes 1 by root 3. Root 3 will go up. This will become root 3. So RA becomes root 3 ohms is the SI unit of resistance. Secondly, RB. This will be 1 by tan 60 degrees. Why tan 60 degrees? Because now the angle that is given to you, this is 60 degrees. So this will be 1 by, and tan 60 is root 3 only. So RB comes out to be 1 by root 3 ohms. All right, so note it down. And as soon as you complete it, just write done in the chat box so that I know that all of you have completed it.
Teacher, I'm done.
What about others? Done?
Done, ma'am.
Atif, Fatma, rest of you, Hiba. Kulsum, Huzaifa, done?